Factorising. Factorising is the opposite process of expanding brackets. It takes an expression and places it into brackets. So one of the ways we talked about expanding brackets was to use a grid method. So if we have 2 on the outside and x and 3 down the side, we know to expand the brackets, we find the area of each square. So 2 multiplied by x would be 2x, and 2 multiplied by 3 would be 6, in which case we get 2x plus 6. Now factorising works the opposite way. So what we can do is we can actually think, well, what do we multiply together to get 2x and 6? So it's working the other way. So we're looking and saying, well, something must be in common between the 2x and the 6, and that would go up here. And hopefully we can see that a number that divides evenly into 2x and 6 would be 2. And then to find the area, 2 multiplied by what gives you 2x? Well, that's going to be x. And 2 multiplied by what gives you 6? That's going to be 3. So then we can say that it's 2 upon x plus 3. So it's the reverse process of expanding brackets. And there's a couple of different ways in which we can do that. And the first of which is common terms. So just what we've done already. So we look for factors in common to them all, and you place the common factor outside the bracket and then divide each term in the expression by that common factor. So in example A, we've got 3x plus 12. What we can look at we should be able to identify that the common factor there is going to be 3. So 3 divides both 3x and 12. So 3 is the common factor, and we put that outside the bracket. So 3 multiplied by the first term must give you 3x, so that's going to be 3 times x. And 3 multiplied by the second term should give you the 12, so 3 times 4 is equal to 12. So that's it factorised. The second one, 3x squared minus 9, if we look at the numbers, 3 is common, but also then they both have an x, one's got x squared and one's got x, so 3x is the common factor here. Then inside we need to think, well, 3x multiplied by what gives us our 3x squared, that's 3x multiplied by x, and then 3x multiplied by what gives us minus 9x. So 3 3s are 9, so it's going to be a 3. We've already got the x, but because it's a negative 9, it's going to be minus 3, so that's fully factorised there. 10ab plus 5b, what we can see is that number-wise, there's the 10 and the 5, and 5 divides evenly into both of those, so we can put a 5 outside. And then letter-wise, what we can also notice is that they both have a b term there, so b is going to be the common term, 5b. And what we look, 5b multiplied by what gives us 10ab, so we need a 2 to get up to 10, and we need an a to get to ab. 5b multiplied by what gives us 5b, well that's actually 1. So a common mistake there people would do, they would write it as 5b brackets 2a and leave it as that. But that, if we expanded those and we multiply those out, we would get 10ab and we wouldn't get the 5b term. So if you think you don't need a term, quite often you do, and it'll be that plus 1. So just watch out for that. And then in example D, so we need to try something that's common to all 3 terms. So number-wise, we're looking at something common between 3, 6 and 9, and they're all divisible by 3. So we're going to put a 3 outside. And then we have x squared and x cubed. So what we need there is an x, so x is common to those. So we need a bracket. The first term, 3x multiplied by something, will give us 3x, and that's 1. So just like we had in the previous example, we need the 1. Then the second term, we need 3x multiplied by something gives us 6x squared, so 3 times 2 gives us 6. But then we need an x squared, so we need an x in there. And then finally, we've got this 9x cubed. We need 3, so 3 times 3 is 9. And then x multiplied by x squared is x cubed. And that's it, fully factorised. In example E, this doesn't look very nice at all. But what we can see is that each term in the expression has a pi, and they also have an r. So what we're going to do is those two terms are going to be the factors. So we'll put both pi and r outside the bracket. And then inside the bracket, so we've got the pi sorted, but r multiplied by something to get us r to the power of 4 is going to be r cubed. The next one, there's a 3, so we need to put that in. We've already got the pi. We've got an r, we want to get to r cubed, so we need r squared. The third term, we've got the pi covered. We've got 1r, but this is r squared, so we need to do another r. And then the last one, pi r, multiplied by something to get to pi r. Again, that's one of those cases where we need to add in the 1 to make sure that we'll get a pi r if we expand the brackets. F, we've got a squared bc, ab squared c, and 4a squared bc squared. So each term has an a, and the highest power of a that's common is 1. So the first term is a squared, the second term is a single a, and then there's an a squared in the third term, so there's only a single a common. Each term also has a b, and again the highest power that's common is a b, and similarly for c. So what we'll have for f, we'll have a, b and c outside the bracket. We need an a, and just an a for the first term. We need the minus sign, and we need a b for the second. And then for the last one, we need the plus 4. We've got an a, we need to get to a squared, so we need to multiply by a. Our b's are good, they're the same. We've got a c, we want to get to c squared, so we need a 4ac then.